Okay, chaps, this is an optional video. You don't have to watch it. It goes again beyond the AP Maths course. But there are certain things that we're going to go through which I think will help you to understand limits a bit better, but you don't have to watch it. So what we're going to try and do is prove that the derivative of the sine x is equal sine x. You should have by now watched that video where I didn't prove it to you, but I kind of I convinced you to do that, and you used it, and that's the important thing, how to use that, okay? But now we're going to try and prove it. And we're going to prove it in 3 stages. The first 2 stages, we're going to calculate these limits, okay? And then the third stage, once we've got these limits, we're going to use first principle, and we'll get there. Okay, so let's look at these limits. So we'll start with the first one. I've got sine h divided by h, and I'm taking the limit where h is close to 0. Okay, now let's just think about it. Why is that like an interesting limit? Okay, so what happens to h what we've got here? Let's write it naively. Okay, if I put, instead of h, I put 0, so I'll put h 0, and I'll put sine 0. Okay, obviously I can't do that, because you can't divide by 0, but sometimes it's good just to see what we're actually getting. Now sine 0, okay, sine 0 is 0, isn't it? Okay, so we've got that 0 to divide by 0 class here, so we don't know what it is. You know, it could be 0, it could be infinity, and it will probably be a number in between. Okay, so that's what we're going to try and do. Okay, so I'll just set up my circle here. Okay, so what I've done, I drew a circle, a unit circle. Okay, unit circle meaning that OA equal OC, which is equal to 1. The radius is 1. We've got the angle theta here, okay? And I extended it straight all the way to B. And then I put a right angle triangle here, a right angle here. So that means this line BC is tangent to the circle. Okay? Now the first thing I want to do is find out, we'll call that what ABC, we'll call that D. So I want to find out what is AD equal to. Okay? What is AD? Now I know that the AD divided by OA, okay, AD divided by OA, okay, that's going to be sine theta, right? Because it's opposite divided by the hypotenuse. Now OA really is 1. We said OA is 1. So AD divided by 1 is sine theta. I can basically write AD is sine theta. Now I'll do the same thing for this one, for BC. Okay? If I divide BC by OB, I'm going to divide BC divided by OC, because I don't know OB, but I do know OC. BC divided by OC, okay? Opposite divided by adjacent, that's the tan theta, isn't it? Okay? And why did I choose OC? Because I know OC is 1. So again, dividing by 1 is the same as doing nothing, really. So BC is tan theta, okay? So I'm going to put these guys, I'm going to use them in a minute, okay? What I'm going to do now, I'm going to calculate the areas of 2 triangles and a slice of a pie, okay? Let's start with a triangle, so area of this one, okay? I'm going to draw it in dots, okay? So I'm going to have triangle OAC. It's triangle OAC. Can you see that OAC? It's a triangle. Okay. Now the area of the triangle is base times height divided by 2. The base is 1. OC is the base. The height is AD. I just found that, sine theta, and I'm dividing it by 2. Okay. Next thing, I want to find out the area of. Okay, I'm going to just try and draw it a little bit like that. That was the area of this triangle. Okay, this triangle. Okay, I'm going to get rid of that theta. You'll just remember that this theta. Now I want to find out the area of this slice of the pie. Okay, I'm going to try and draw. I don't know if you can see. This is a slice of a pie. It's not a triangle. It's that little, what do we call it? Segment was the word. Okay, it's the same one. It's OAC, but it's not a triangle. Now we're talking about that segment. So I can add. It's basically the same triangle plus that little bit of a section here. It's a little bit bigger, isn't it? Okay, I can even write that. That is a little bit bigger than that. Okay, and that's going to be equal to, if you remember, I'll just have to remind you quickly. Okay, to find out the segment, area of a segment, what I'm going to do, I'm going to take the angle, theta, in radian, divided by 2 pi, which is the angle of a full circle. And if I have the full circle, the area will be pi r squared. Okay, so I'm doing theta divided by 2 pi times the pi r squared. But r, in this case, is 1, so it's pi 1 squared. In other words, just pi. Okay, so the answer is going to be pi and pi cancel out. I'm going to have theta over 2. Okay, alright, so I'm going to just get rid of that to make it a little bit simple. So I've got the area of a triangle. Okay, I've got the area of the pi. Now we're going to move on to the area of the big triangle OBC. OBC. Okay. Now again, I know the base. The base in this case is 1. The height in this case is BC is tan theta, and I'm dividing by 2. So in other words, I've got tan theta over 2. Okay. Over here, I'm also going to rewrite it as sine theta over 2. Okay. So I'm going to rewrite this whole thing. I'll make some space, rewrite the whole thing, and then we'll take it from there. Okay, so I've rewrote the whole thing, but just made it a bit clearer. So we've got the small triangle in blue, the area is sine theta over 2. I've got triangle of the area of the segment, it's that plus that little bit of orange, that's theta over 2. And the area of the big triangle, okay, with that extra green stuff here, which is tan theta over 2. And I've got this inequality. I think it's quite clear. Now, with inequality, I can, just like with normal equalities, I can time by 2. So if I time everything by 2, I basically get rid of that theta. Okay? Next thing, instead of tan theta, I think you can agree with me, I can write down sine over cosine theta. Okay? Next thing what I'm going to do, I'm going to divide by sine theta. So I'm going to divide all that by sine theta. You can do that, right? So divide that by sine theta, divide that by sine theta, and divide that by sine theta. If I divide that by sine theta, that basically cancels out with that. So I've got 1 over cosine theta. If I divide sine theta by sine theta, I really get 1. Okay, so now we've got that equality. Okay, now comes the punchline. Okay, if I then take the limits, I want to take the limit where theta approaches 0. Okay, here I used h, here I use theta, but it's the same thing. Okay, I can call all that h, it doesn't matter. Okay, we'll stick with theta. If I write the approach, well, the same thing, but with the limit, I'm going to see that 1. Well, 1, and the limit with theta approaches 0, 1 is always 1. Okay, here I'm going to write limit of theta approaches 0, not 0, theta over sine theta. And then what is 1 over cosine theta? What happens to cosine theta? What is cosine 0? And what is cosine 0? Okay, because theta approaches 0. Cosine 0, hopefully by grade 12, you know it's 1. So that's 1 divided by 1, it's 1. What did I show here? That as I approaches 0, as theta gets closer and closer to 0, theta over sine theta is at the same time larger than 1 and smaller than 1. Now, if I was a little bit more careful, I should have put these equal signs. So it's always larger or equal. Okay, and this is a technique that we use a lot in maths in university. Okay, to prove something, you show that it's also larger than a value or equal, or smaller or equal than another value. That's called, we can call it a sandwich method. Okay, so if that is both larger or equal than 1 and both larger or smaller or equal to 1, then in other words, okay, in the limit where theta approaches 0, theta over sine theta obviously is equal to 1. Obviously. Okay? But now I'm just noticing, actually, instead of theta divided by sine theta, or h divided, I mean, of course, I could just do h divided by sine h. Okay? That's just a different method. But now I realize that over here, I wanted sine h divided by h. But that's obviously the same thing. If h divided by sine h is equal to 1 when h approaches 0, then obviously sine h divided by h is also going to be 1. Okay? Because what does that mean? H and sine h are very, 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 very similar when h is equal to 0. So if I'm doing the reciprocal, it's also going to be 1. Okay? So hopefully that explains that. Let's pause and make space. Okay, that was actually the hardest bit in the proof, in the whole proof. Next bit is a bit easier. So I want to find out what's the limit of cosine h minus 1 divided by h. Now, again, let's do this naive way. So what is cosine 0? Cosine 0 is 1. So it's going to be 1 minus 1 divided by h, which is 0. So I've got, again, the situation of 0 divided by 0, which we don't know what it is. It could be finite, infinite, or even 0. Okay? So the trick to do here is, and again, you wouldn't have thought about it before you've done it. It's one of these things that you learn. Okay? You time the top and the bottom by cosine h plus 1. Okay? Like I told you guys, this is really beyond the level that you need to know for AP. There won't be questions like that. Obviously, I can time the top and the bottom by the same number. That's like timing by 1. Okay? But you can probably see what's happening here. Okay? Cosine h minus 1 times cosine h plus 1, that's, what do you call it? Difference of a square is going to be cosine squared h minus 1 divided by h cosine h plus 1. Okay? Now let's play with that. I should have really wrote limits. Yeah, limits, h approaches 0. Let's write that as, instead of cosine square h minus 1, write it as 1 minus cosine square h. Okay? I'll keep the denominator the same. But obviously, if I swapped it, I need to put a minus there. Right? Right, what is 1 minus cosine square h? Again, at this point, I'm pretty sure you've done this identity. Hopefully, in your mind, straight away, it's screaming to you that this is simply sine square h. Okay? And again, I haven't done anything with the bottom, really. Now I'm going to do something a bit weird. Instead of writing sine square h, I'm going to actually spread. What is sine square h? It's sine h times sine h. Now, why am I doing that? I'm doing it because I've got some kind of ratio, sine h over h. Okay? In the limit where h approaches 0, I know that's equal to 1. So I can replace this whole thing by 1. So I'm going to have limit h approaches 0. I'll have the minus. Okay? Don't need another equal here. So minus. Instead of that, that's just 1, so I don't need to write it. So I'm going to write minus sine h divided by cosine h plus 1. Okay? At this point, this is one of the things you got to do with limit. Once in a while, you start this kind of journey, play around, and then see if you can actually substitute it. Because as in the beginning, if you put h equals 0, you can't do it because you got 0 divided by 0. But now let's just try and put 0. Okay, so it's going to be minus sine 0 divided by cosine 0 plus 1. Okay? Now, what is minus sine? What is sine 0? Sine 0 is 0. Okay, so it's going to be 0. Okay, let's see what we have in the bottom. We also had a 0 at the top here, but then we had 0 at the bottom. So let's see if we still have 0 at the bottom. Here I've got cosine 0 plus 1. Cosine 0 is 1. So here I have 2. So in other words, okay, this limit is actually 0. Okay, so we've got one limit which is 1, another limit is 0. And now we're ready to use first principles. Okay, so the reason, is this working? The reason why this kind of question you don't need to do for AP is that to calculate these limits, we haven't really learned it. So I've taught you now that that's beyond the course. But what they can ask you, they could give you these limits, and knowing these limits, now use first principle to show that d sine x to dx is cosine x. Okay, because first principle, we definitely need to know how to do it. So how do we use first principle? Okay, basically, okay, I'm taking the limits where h approaches 0. I'm going to add a little bit of an h to that x, minus sine x, and divide by h. Okay, so I took the value of sine x at h step forward, a small h, take the difference, that's the delta y, okay? I'll write that in brackets. That's the delta y, the difference in the y value, and that's the difference in the x value. And we're taking a small difference in x, almost 0. Okay, now what you got to do here, you got to use a trig identity, okay, which I don't know if you've learned it yet. So we did speak about it at some point in the class. I'm going to write it down here. Sine A plus B. Okay, so you will learn something like that if you haven't yet. And if you have a plus b, it's not just sine A plus sine B. That will be too easy. Okay, what you have is sine A cosine B plus cosine A sine B. So that's a trig identity that you will learn for core maths. Okay? And we're going to use that one. Okay? So I'm going to write limit h approaches 0. Okay? My A is x, my B is h. Okay? So I'm going to write sine x cosine h plus cosine x sine h. That's this business. Then I need to minus sine x and divide by h. Okay? Now I'm going to split into two fractions. Okay? H approaches 0. I'm going to take, first of all, what should I take? I'll take those two. And I'll take I'm going to take these ones. So that's 1 and that's 2. I'll put them together. And I'll take a factor, sine x out. So I'm going to be sinus x cosine h minus 1. Right? That's just factorizing these two terms. And I divide by h. Okay? That's term 1 and 2. And then I'm going to add to that the third term. Okay? That's the third term. So that's 1 plus 2. And then the third term. The third term is simply cosine x sine h. And again, I divide by h. Now, just look at this for a second. Just look at this. Okay? Before I carry on, I want you just to pause me. Look at these limits. Okay? If you're really interested in doing this video, then obviously you really enjoy maths. Okay? Just look at these limits that we found. Look at this two fractions, the sum of two fractions, and see if you can use these limits to find what it is. Just pause me. Okay? Take 2 minutes and watch it. Okay. Maybe it worked, maybe it didn't. Okay? Now let's have a look at this. What do I have here? I've got sine x times this business. Okay? The limit where h approaches 0, cosine h minus 1 divided by h. That's that one. Cosine h minus 1 divided by h. When h approaches 0, we get a 0, right? That's times 0. So I've got sine x times 0, which is obviously 0. So didn't get anything in. Next thing, I've got cosine x. And now I've got, let's use another color. I've got sine h over h. Okay, I don't have that. I've got sine h over h. What is sine h over h? Aha, that's 1. So we're going to time that by 1. So you can see, okay, I'll remind you what we're actually finding here. We find the derivative of sine x to dx. Oops. D sine x to dx. And what we found this time, and what we have is that this is simply cosine x. Okay? So that's quite a long proof. Hopefully you had fun. Again, you don't need to know it for the AP. Cheerio.